A rational equation is an equation that contains fractions with x's in the numerator, denominator, or both. Here's an example of a rational equation. 4 over x plus 1 minus 3 over x minus 1 equals negative 2 over x squared minus 1. Let's think back for a moment about solving an equation with a fraction. 1/3 x equals 8. We think of the 3 in the denominator as being a prisoner, and we want to release it. To set the 3 free, we multiply both sides of the equation by 3. Think of it as 3 letting both sides of the equation know he's leaving. 3 times 1/3 x equals 8 times 3. This process freed our denominator and got rid of the fraction. X equals 24. It is also the process we use to solve rational equations with one extra step. In rational equations, sometimes our solution may look good, but they carry a virus. That is, they won't work in our equation. These are called extraneous solutions. The steps to solve a rational equation are: find the common denominator, multiply everything by the common denominator, simplify, check the answer or answers to make sure there isn't an extraneous solution. Let's solve a couple together. Example number 1. Solve. Remember to check for extraneous solutions. 3 over x plus 3 plus 4 over x minus 2 equals 2 over x plus 3. Our first step is to figure out the terms that need to be released from the denominators. I look at 3 over x plus 3. I write down x plus 3 as one of my common denominators. I look at 4 over x minus 2. I write down x minus 2 as another part of my common denominator. I look at 2 over x plus 3. Since I already have x plus 3 written in my denominator, I don't need to duplicate it. Next, we multiply everything by our common denominator, x plus 3 times x minus 2. This is how that will look. 3 times x plus 3 times x minus 2 over x plus 3, 4 times x plus 3 times x minus 2 over x minus 2 equals 2 times x plus 3 times x minus 2 divided by x plus 3. It isn't easy for the denominators to be released. There is a battle, and like terms in the numerator and denominator get canceled or slashed. Slash or cancel all of the x plus 3's and x minus 2's in the denominator and numerator. Our new equation looks like 3 times x minus 2 plus 4 times x plus 3 equals 2 times x minus 2. Distribute to simplify. 3x minus 6 plus 4x plus 12 equals 2x minus 4. Collect like terms and solve. 3x plus 4x is 7x. Negative 6 plus 12 is 6. We end up with 7x plus 6 equals 2x minus 4. Subtract 2x from both sides. 7x minus 2x equals 5x. Subtracting from the other side just cancels out the 2x, and we get 5x plus 6 equals negative 4. Subtract 6 from both sides. Negative 4 minus 6 equals negative 10. Again, subtracting 6 will cancel out the positive 6, so we end up with 5x equals negative 10. Divide by 5 on both sides, and we cancel out the 5 and give us x equals negative 2. It turns out x equals negative 2. The reason we check our answers is that sometimes we get a virus, or, in math terms, extraneous solutions. To check, I replace all of the x's with negative 2. 3 over negative 2 plus 3 plus 4 over negative 2 minus 2 equals 2 over negative 2 plus 3. Let's simplify. 3 over 1 plus 4 over negative 4 equals 2 over 1. Since 3 plus negative 1 equals 2 is true, x equals negative 2 is the solution. Example number 2. Solve. Remember to check for extraneous solutions. 4 over x plus 1 minus 3 over x minus 1 equals negative 2 over x squared minus 1. First, we need to release our denominators. To release our denominators, we write down every denominator we see. I have found the easiest way to do this is to first factor if needed, then list the factors. X squared minus 1 equals x plus 1 times x minus 1. Our new equation looks like this. 4 over x plus 1 minus 3 over x minus 1 equals negative 2 over x plus 1 times x minus 1. I look at 4 over x plus 1. I write down x plus 1 as one of my common denominators. I look at 3 over x minus 1. I write down x minus 1 as another part of my common denominator. I look at negative 2 over x plus 1 times x minus 1. Since I already have those written in my denominator, I don't need to duplicate them. So my common denominator turns out to be x plus 1 times x minus 1. Catherine, why aren't we using the factors of x squared minus 1? Great question. We already have x plus 1 and x minus 1 being released. We don't need to do it twice. Now, we multiply each part of the equation by the common denominator, x plus 1 times x minus 1. Think of this as the key to the prison. 4 times x plus 1 times x minus 1 over x plus 1 minus 3 times x plus 1 times x minus 1 over x minus 1 equals negative 2 times x plus 1 times x minus 1 over x plus 1 times x minus 1. It isn't easy for the denominators to be released. There is a battle, and like terms get canceled or slashed. Slash or cancel all of the x plus 1s and x minus 1s in the denominator and numerator. This leaves us with 4 times x minus 1 minus 3 times x plus 1 equals negative 2. Now we need to solve for x. Distribute 4 into x minus 1 and negative 3 into x plus 1. 4x minus 4 minus 3x minus 3 equals negative 2. Collect like terms. X minus 7 equals negative 2. Add 7 to both sides of the equal sign. X equals 5. It looks like our answer is 5, but we need to double check. I replace all of the x's with 5 and simplify. It turns out 5 works, and it is the solution to our equation. And so our solution checks. The steps to solving a rational equation are: find the common denominator, multiply everything by the common denominator, simplify, check the answer or answers to make sure there isn't an extraneous solution.